Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, we're going to be talking about algebraic fractions, which is a topic that frequently appears on both the arithmetic reasoning as well as the mathematics knowledge subtest of the Armed Services Vocational Aptitude Battery, that is the ASVAB. In order to get the most out of today's video, I strongly encourage you to make an effort to work out as many of the practice problems that you see on your own scratch paper as possible. That is, after I read a question, you should pause the video, attempt to work it out on your own, and then resume playing the video to see if you and I came up with the same solution. For this video, I'm assuming that you know how to add, subtract, multiply, and divide fractions. And in addition, I'm also assuming that you know how to do some basic algebra, including factoring. If during the time you watch this video, you feel as if you're struggling with any of those things, just take a look on my channel. I do have videos in regard to fractions as well as factoring. And I'm going to go ahead and post a link to those videos in the description of this video. All those things being said, let's go ahead and get started with some practice. For this first problem, you can see that we have x over 3 plus x over 4. That is, we're trying to add these two fractions. In order to add fractions, you have to have denominators that are the same. In this case, the denominators 3 and 4, which means we can't add these just yet. One way to find a common denominator is to list out factors of each of the denominators. So for 3, we know the factors of 3 are 3, 6, 9, 12, and so on. And as far as factors of 4 go, they are 4, 8, 12, and 16. As we can see, both of these have a least common multiple of 12. So that's going to be our least common denominator for this pair of fractions. In other words, we're going to rewrite both these fractions with a denominator of 12. So let's go ahead and set that up. All right, so in order to make 3 12, we're going to have to multiply it by 4, given that 4 times 3 is in fact 12. What we're going to do to the denominator over here, we also have to do to the numerator. So that's going to be 4 times x, or 4x. Similarly, to make 4 12, we have to multiply it by 3. And then we're also going to have to do that to its numerator. So that's going to be x times 3, which is just 3x. Now we can go ahead and add these fractions, since as we can see the denominators are the same. So this becomes 4x plus 3x all over 12. Let's add these like terms. 4x plus 3x is 7x over 12. And as you can see, 7 is a prime number, so we can't simplify this any further. And therefore we know, in simplest terms, x over 3 plus x over 4 is 7x over 12. Again, this is exactly how we would deal with a regular fraction. The only difference is we have this variable x now, which makes it an algebraic fraction. All right, let's move on to the second example. All right, for this one, you can see that we have w over 2 minus w plus 1 over 7. Again, we're subtracting algebraic fractions. That said, we're doing that albeit with denominators that are different, notably 2 and 7. In order to do this subtraction, we have to rewrite these fractions such that their denominators are the same. So one way to do that is to list out multiples of 2 and 7 and then find their least common multiple. So that's going to be 2. Factors of 2 are 2, 4, 6, 8, 10, 12, 14, and so on. And factors or multiples of 7 are 7, 14, 21, and so on. And right away we should see that these have a least common multiple of 14, which means we're going to use 14 as their least common denominator. In other words, we're going to rewrite these fractions such that they both have denominators of 14. Okay. In order to make 2 14, we have to multiply it by 7. Given that 7 times 2 is 14, we're also going to have to do that to its numerator. 7 times w is 7w. In order to make 7 14, we have to multiply it by 2. What we do to its denominator, we're also going to have to do to its numerator. And that's going to be 2 times all of this. So that's going to be 2 times w plus 1. All right, let's try to simplify this. As my next step, I'm going to work out this 2 times w plus 1. So this becomes 7w over 14 minus, and let's distribute this 2 to this w as well as to this 1. So that's going to be 2 times w, which is 2w, plus 2 over 14. Let's keep working this out. Again, now that the denominators are the same, notably 14, we can go ahead and do this subtraction. This becomes 7w minus 2w, and then minus 2. Okay, so let's work that out by combining like terms. 7w minus 2w is 5w minus 2 over 14. And in light of the fact that we can't factor anything out, this is in simplest terms. All right, in this example, you can see that, again, we're trying to add these algebraic fractions, albeit with different denominators, notably 2w and 3w. Again, as we would with normal fractions, we're going to list out factors of the denominators so that we can find their least common multiple, and we'll set that to be their denominator. So we got factors of 2w are 2w, 4w, 6w, 8w, and so on. Factors of 3w are 3w, 6w, 9w, and so on. And as we can see, they have a common factor of 6w. So in other words, we're going to write these algebraic fractions such that they're both over a common denominator of 6w. So let's go ahead and work on doing that. In order to make 2w 6w, I have to multiply it by 3, given that 3 times 2w is 6w. And I'm also going to have to do that to its numerator. 3 times 3 is 9. In order to make 3w 6w, I have to multiply it by 2. And then I'm also going to have to do that to its numerator. Again, 3w times 2w is 6w. 5 times 2 is 10. Given that these now have the same denominator, all we have to do is just add them now. So this is all going to be over 6w. And this is going to become 9 plus 10. So that's going to be 19 over 6w. And we cannot reduce this any further. So that's what we're left with. In this next example, you can see that we're trying to do subtraction of algebraic fractions, albeit with different denominators, notably 3y and 5y. So in order to do this, we have to rewrite these algebraic fractions such that they have the same denominator in order to do the subtraction. So let's list out some multiples of 3y and 5y. Again, multiples of 3y are 3y, 6y, 9y, 12y, 15y. Multiples of 5y, that's going to be 5y, 10y, 15y. And as you can see, they have a common multiple of 15y. So we're going to rewrite these fractions such that they're both over 15y like this. It's going to be 15y, and the denominator for both of them. All right, in order to make 3y 15y, we have to multiply it by 5. Given that 5 times 3y is 15y, we're also going to have to do that to the numerator. So that's going to be 5 times 2 are 10. In order to make 5y 15y, we're going to have to multiply it by 3. And we're also going to have to do that to its numerator. So this is going to be 5y times 3, which is 15y. 1 times 3, which is 3. Now we can do the subtraction. Again, we're just subtracting what's in the numerators, and the denominator is going to stay the same. So this becomes 10 minus 3, which is 7 over 15y. And since we can't factor out a common term between 7 and 15, we can't reduce this any further. All right, so in this example, we're trying to add algebraic fractions, and as we can see, their denominators are different. We have x plus 1 and x plus 2 as our denominators. In order to add these fractions, we need to make the denominators the same, but this pair of denominators is unlike anything we've seen so far. We could list out the multiples of x plus 1 as well as x minus 2 in an effort to find a common denominator. But that said, the best approach to dealing with problems like this is to simply multiply the denominators by one another to create your common denominator. So let's go ahead and do that. Again, I'm going to multiply x minus 2 by x plus 1. And then I'm going to multiply x plus 1 by x minus 2. Again, I'm just multiplying the denominators by each other, and that's going to give me this common denominator. It's going to give me the denominator of x minus 2, x plus 1, and that's how we're going to rewrite these fractions. And then, of course, this is plus over x minus 2, x plus 1. All right, and as we just saw, in order to make this fraction have a denominator of x minus 2, x plus 1, we multiplied it by x minus 2. We're also going to have to do that to its numerator. So this is going to become 1 times x minus 2. 1 times anything is just itself, so this is just going to be x minus 2 in this numerator. In order to rewrite this fraction such that it had a denominator of x minus 2, x plus 1, we had to multiply it by x plus 1. So we're going to do that to its numerator as well. So this numerator is going to become 4 times x plus 1. All right, before we add these, let's go ahead and work out this 4x plus 1. So again, this is equal. We're not going to touch this fraction just yet. It's x minus 2 over x minus 2, x plus 1 equal, or plus, sorry about that. And let's distribute this 4. It's going to be 4 times x, which is 4x, and then 4 times positive 1, which is going to be plus 4. Again, this is all over x minus 2, x plus 1. And that's a bracket. My pen's starting to act up a little bit. Now we can go ahead and combine these into one fraction. So this is going to be all over x minus 2, x plus 1. And then we have x minus 2 plus 4x plus 4. Let's combine like terms. We have x and 4x, so we can combine those to be 5x. And then we have negative 2 and 4, which is just going to be positive 2. So as we can see, this reduces to x minus 2, x plus 1 in the denominator. And since we can't factor anything out to cross out these anything else, this is in simplest terms. And let me get rid of that work so we can have room to work on this one. All right, again, we're trying to add fractions, algebraic fractions, that have different denominators, notably 4 and 3. Again, in this case, it'd be helpful to list out some multiples of 3 and 4. So multiples of 4 are 4, 8, 12, and 16. And multiples of 3 are 3, 6, 9, and 12. As you can see, they both have a common multiple of 12. So in other words, we're going to rewrite both these fractions such that they have a denominator of 12. So let's go ahead and set that up. Okay. To make 4 12, of course, we have to multiply by 3. Given that 4 times 3 is 12, we're going to have to do the same thing to its numerator. So we're going to have to multiply all of that by 3. So as we can see, that becomes 3 times 3x plus 1. Similarly, in order to make 3 12, we have to multiply it by 4. And we're also going to have to multiply its numerator by 4. So this is going to become 4 2x minus 1. All right. Before we do anything else, let's take care of this distribution that we have to do. Again, we're going to have to distribute 3 to 3x and 3 to 1. And then similarly, we're going to have to distribute 4 to 2x and 4 to negative 1. So let's go ahead and do that. Again, these are still going to be over 12. 3 times 3x is 9x. 3 times 1 is just 3. 4 times 2x is 8x. 4 times negative 1 is negative 4. Now we can combine these to be over 12. Again, that's going to be 9x plus 3 plus 8x minus 4. Let's combine our like terms. We have 9x and 8x, so that's going to be 17x. And then we have 3 and negative 4, which is going to be negative 1. Of course, this is all going to be over 12. In light of the fact there's nothing we can factor out, we now know that this is in simplest terms. Okay, so that was that one. Let me get it out of our way so we can work on this other example next. All right, in this example, you can see that we're multiplying algebraic fractions. And as you may recall, in order to multiply fractions, you just multiply straight across. So in this case, we're just going to multiply the numerators and then multiply the denominators. In other words, this is w times w over 2 times 4. W times w is w squared over 2 times 4, which is 8. Okay? So that's that one. All right, again, we're multiplying algebraic fractions, so we're going to multiply straight across as we normally would with fractions. This is going to become 3a times 4, and then 2 times 5a. 3a times 4 is 12a, and then 2 times 5a is 10a. In this case, we can cross out these a's, and then we could even reduce 12 and 10, since they're both divisible by a factor of 2. 12 divided by 2 is 6. 10 divided by 2 is 5. So in simplest terms, this algebraic fraction reduces to 6 over 5. Okay, so that's that one. All right, let's get some practice doing division involving fractions. Again, in order to do division with fractions, you do keep, change, flip. That is, you keep this first fraction the same. W over 2 is going to be the same. You're going to go from division to multiplication, so that's your change. Again, keep the first fraction the same. Change from division to multiplication, so this becomes multiplication. And then flip this second fraction, so it becomes 6 over w. Now we're just multiplying algebraic fractions, which means we're just going to multiply straight across, and you could reduce if you wanted to, but we're not going to do that just yet. This becomes 6 times w, or 6w, and then 2 times w, which is 2w. All right, we can cross out these w's. 6 over 2 is just 3. So we can see that this one reduces to 3. And we have 3 more to go. All right, again, we have another instance in which we're doing division and algebraic fractions. So again, we're going to do keep, change, flip. That is, we're going to keep this first fraction the same, so it's going to be v plus 3 over 2. We're going to change from division to multiplication, so this becomes multiplication now. And then we're going to flip this second fraction, so it's going to be 5 over 3v plus 9 instead of 3v plus 9 over 5. Again, now we're just going to multiply straight across. And this is going to become 5 times v plus 3. And this is going to become 2 times 3v plus 9. That looks like an A, so let me fix that real quick. All right. And that's going to be, let's see if we can simplify this one. So I'm going to actually multiply this out here and here. That's going to be 5v plus 15. That one's already simplified, so there's nothing to do there. That said, we might be able to simplify this denominator by working it out. So let's leave the numerator the same for a second. It's going to be 5v plus 3. 2 times, and again, we're going to distribute that there and there. 2 times 3v is 6v. 2 times 9 is 18, so that's going to be plus 18. And again, our goal is to try to cross stuff out if possible. Let's see if we can do that. Let's factor out a 6 in the denominator and see what that does. Again, this becomes 5v plus 3. Factor out a 6. This is going to become 6v plus 3. And again, this is going to enable us to cross out these v plus 3's, which will just leave us with 5 over 6. Okay, so the answer to that one is 5, 6. And sometimes you have to play with these factors until you can cross some of them out. In this case, I thought I would have to multiply out the numerator. That didn't work out, but I multiplied out the denominator, and then I factored out a 6, which enabled me to cross out the v plus 3's. Okay, so that was that one. All right, for this one, we have an algebraic fraction, and more specifically, we have quadratics in the numerator as well as the denominator. Whenever you see this, you should realize that you can probably factor these quadratics, and we factor those like this. These are always going to be x's if they're factorable. So let's go ahead and work on factoring this. And again, I have a video on factoring if you don't follow along what I do here. I'm not going to explain every step I do here because I'm assuming you know how to do some basic factoring. So for this numerator, if we're trying to factor it, we're looking for two factors that multiply to positive 2 and add to negative 3. So that's going to be negative 2 and negative 1. Again, negative 2 times negative 1 is positive 2. Negative 2 plus negative 1 is negative 3. All right, so for this bottom quadratic, we're looking for two factors that multiply to negative 6 but add to positive 5x or 5. So that's going to be plus 6 minus 1. Plus 6 times negative 1 is negative 6. Plus 6 minus 1 is 5. Okay? To simplify this one, we can just cross these out. That leaves us with x minus 2 over x plus 6. And now this algebraic fraction is in simplest terms. All right, finally we have this one. We're trying to subtract a pair of algebraic fractions. In order to do subtraction, you have to ensure that these fractions have the same denominators. And in order to make these the same, I can multiply this one by w, which will give us a common denominator of w plus 3 for this one, and w plus 3 for this one. As you can see, I'm not going to have to make any adjustments to this one since its denominator already is w times w plus 3. So this one's just going to be 5. For this one, however, I had to multiply its denominator by w. So I'm also going to have to multiply its numerator by w, which is going to become w squared. All right, and since their denominators are the same, I can go ahead and combine these now. Again, this is going to be w squared minus 5 over w plus 3. And this one, it turns out, is in simplest form since I can't factor out w squared minus 5. Okay? So that's it for today's video. Again, we talked about algebraic fractions, and we looked at almost all the variations you'll see on the ASVAB. I hope you found this video helpful. As always, you're more than welcome to leave some feedback in the comment section below. If you need more help, look in the description of this video for links to my videos on fractions as well as factoring. But on that note, I'm going to go ahead and cut you loose. こんにちは。